Welcome back to another HVAC Engineering Techie training video. These training videos are intended to be educational and are intended to help you with your career. Today's lesson is HVAC Residential Package AC Systems, which is S-2 training. So I hope you've already looked at the standard basics, which learned about what's inside of a package unit and what's available, what's not. And this is how that system is actually used in the different kinds of package units. So this is for constant volume residential package units. So remember, this channel talks all things HVAC, engineering design, construction, equipment, systems, test and balance, controls, efficiency, and performance. Before we get started, I'd like to ask you a big favor. Please become a subscriber. This really helps me. It's totally free. It doesn't cost you. You just have to hit that button down below, so subscribe. Give me a thumbs up if you would. And that just tells Google that you're appreciating these videos, and it'll keep me on the air, and I'd appreciate it. So let's get started looking at residential package systems. All right, so now we're going to talk about residential package units. This first one is an AC unit, which is a cooling-only unit that has a heater in it for heating if you need it. They don't all come with heat. You have to order it that way. So basically, here's a package unit, a standard package unit. The package unit has a fan, which is normally in the draw-through. So basically, the air is drawn through the return system, across the filter, across the electric heater, if it has one, through the evaporator coil, through the fan, out to the space. And that's the airflow of the system. And then it has a refrigeration system. And in this particular one, I've showed the refrigeration section being on the back of the unit. However, they might be on top of the unit, they might be on either side of the unit or both sides of the unit, wrap around the unit. You never quite know how they're going to build them. But I've shown it this way so we can clearly see what it is. Then there's a refrigerant circuit. The refrigerant circuit includes a compressor, a condenser coil, and a condenser fan, and an evaporator coil. So as the gas comes out of the refrigerant coil, it's a vapor. It's a vapor with real small refrigerant droplets in it, which carry the heat. And it comes to the compressor, and the compressor compresses it. And as it compresses it, it heats it up. That's part of the physics of matter. If you take a gas and you compress it, you will heat it up. The hot gas, which is called, hot gas goes into the condenser coil, where the air flowing across that coil condenses that gas into a liquid. And the liquid then goes over to an expansion device, which is normally an expansion valve. It might be a cap tube, but it's a device that allows it to expand. So it expands the gas. And as the gas expands, it gets really cold. And so that the expansion valve allows it to expand, and cold gas goes into the evaporator coil, and the air across it now warms the gas up or cools the air, whichever one you want to say. So it cools the air, and then it returns. So that's the refrigerant circuit. Now, all package units have the same thing. They have an internal control system that actually controls everything in here. It controls the compressor, the condenser fan, the strip heater if it has one. It controls this side of it. It controls this fan. And the way it communicates with the outside world, a standard package unit for residential would have a thermostat on the wall, and it'll have a terminal strip in here that connects to the internal control system. It'll have an R terminal for red wire, and that's the voltage. It's got 24 volts on it. It's the hot wire. And then you'll have a green, a G for green, and that's that runs the supply fan. You'll have a Y, which is for yellow, and it runs the compressor. You have a W for heating, and it'll run the strip heater. And it'll have a C for common. Now, most of the time we don't need a common unless this thermostat has a computer in it or something where it needs to use power. See, a regular, normal old thermostat that just had a bimetal contactor or a mercury contactor in there, it didn't use any power. It just runs the power through it. So if the unit's giving you 24 volts here, it goes through the thermostat, the switch makes its contact, it comes back and starts the fan and the compressor. So that's the way those work. And so this is a standard connector into the package unit. Now, the thermostats all have sub-bases on them, and the sub-base is a switch base. Now, you can get all kinds of different switch bases for almost every kind of thermostat. So this switch base normally has at least 2 switches on it. They can have more, but normally this one switch is to turn the unit on and off or put it in auto, so it can bring itself on and off depending on temperature. And the other side might be heat, cool, or auto. or it could be another kind of switch. But those are the switches that allow the homeowner to be able to switch this unit on or change it. And then, of course, it has a temperature set point so they can change the set point. Now, for most homeowners, they really need to have more than just a standard thermostat, because this thermostat only controls the unit to temperature. It doesn't matter time of day or what day it is. It's on or off based on temperature. Well, normally we want to have a programmable thermostat where we can tell it we want it on this time of day for Monday through Friday. We want it on this time of day for Saturday, Sunday, anytime. Most of them are 7-day time clocks where we can set different temperatures and we can set different times a day. This makes it a little bit more energy efficient. Now, why did I break off residential systems from commercial systems? Package units are the same. Well, I didn't want that video getting really, really long, so we'll take in the residential and put a lot of stuff in the residential so that the commercial one can be a little shorter. But the main reason we separate them is because the residential units are normally 1.5 to 5 tons, and commercial units are 6 ton and above, 6 tons, 100, 120 tons. So they can get really large, they can go much in size. The main difference between the two, now, by the way, these residential units, we use them on commercial all the time, is size. So if we need a 2-ton unit on a commercial job, it'll be a residential unit. They don't make a 2-ton commercial unit. And there's really no difference. The main difference is in cost. Because on these residential units from 1.5 to 5 ton, they make millions of those. In commercial units, they only make thousands of those. So the difference because of volume is cost. These residential units cost much less per ton than a commercial unit. So that's why we use a lot of them. Okay, so now if we have this in commercial system and we want to use it differently, we'll show you how you put a DDC system on this. Now these sequences, this actually is a sequence of a thermostat. All these sequences I'm going to review for you today are just high-level sequences intended to explain what the unit does. These are similar to what an engineer would put on the drawings. These are not programmer sequences. They don't include timers. They don't include any reset outs. They don't include any exit points. So they're not really intended for a programmer. So for the thermostat, the unit is enabled when the sub-base is switched on. So when the switch is on, the unit is on. Unit control cycles the compressor and condenser fan to provide cooling when the cooling is required. So when the temperature gets too hot, the the element inside this thermostat closes the Y connection and off, and then the controls in here turns on the compressor. The internal controls have all kinds of refrigerant safeties. They have low suction pressure, they have high pressure, and they have temperature of the gas. So there's certain things they watch and have logic in here to say, okay, we're going to damage the compressor, we're going to shut it off. So there are some things in here that this control system does that aren't overridden by the outside controller. And let me say, that's a good thing. You would not want a DDC control system that we've overlaid on here trying to run the safeties in this refrigerant circuit. That would not be a good thing. So unit control cycles the electric heater when the heat is being used. So if you have a strip heater in it, you can use the white wire, and that'll turn the heat on and off. So that's a standard for a residential system. Now, if we use it commercially, we'll put a DDC controller up here, and we'll just put relay outputs to each one of these points. So basically, we can enable the unit. We can then turn on any one of these. So again, the unit gives us power. It goes into the controller, the other side of the relay. When the controller closes it, it'll come on. It'll turn on whichever one these want, just like the thermostat, except it's coming in from the controller. We have a room sensor. We would probably put a supply air temperature sensor, mainly because it's the cheapest unit status point we can get. So we would do that, and then we'd probably have an outside air damper that's going to close when the unit's off, so no air infiltrators could come on. And then it's going to open up to the minimum set point, whatever it is, when it's on. Now, most residential units don't have outside air intakes, but they should. They just don't, because normally houses were so leaky you didn't actually need one. But nowadays, houses are built fairly tight. You really should have a way to get ventilation air into the space. And the way to do that is, of course, for an outside air intake right into the return air plenum. All right, here's a typical sequence for a commercial. The fan shall be on and the outside air damper open when the schedule is in the occupied mode. Cycle the compressor and heater to maintain space temperature set point. Really a simple sequence. So now let's look at a unit with a gas heater. It's exactly the same as the other unit, except it's got a gas furnace in here. And this gas furnace is a standard furnace, probably purchased from some manufacturer. They install it in the factory. It has a gas valve. It has the internal fire. It has a flue, and it has a way to get rid of the flue gas. So this is just like the other unit. It's got a residential, the residential thermostat connects to these lugs just like the other one. Oh, I should mention, there are some manufacturers out there that make AC units, and they also make control systems, like Trane. Others haven't, but Trane has gone so far as to, on their smaller units, they basically only have one of their controllers in here. They don't have these lug points for you to land a thermostat on. So you must use a thermostat sensor, a Trane sensor on it, because it's an electronic sensor. It's not a regular stat. However, if you want to put it in a system differently or attach it to a DDC system that's not Trane, then you buy a little module and it connects into their internal network and provides these points. So you can do it, but you have to buy that extra piece. 15 years ago, it was like $250. Might be $400 nowadays, I'm not sure. But that's how you do that. So regular thermostat control would be unit is enabled when the subbase is switched on. Unit control cycles the compressor and the condenser fan to provide cooling when cooling is required. Unit control cycle the gas unit when heating is required. Now there are internal controls for the gas furnace because there's some different control in here. Like when you turn off a gas furnace, not everything stops because it needs to get the gas, the flue gas, out of the unit. So it'll have a condenser blower that will continue to blow until this gets cool. Then it knows it's got all the combustion gas out of the unit. They don't want the combustion gas sitting here because it will condense and it will damage these tubes, so they don't do that. So they will do that. Now, if you do it, when I use this commercially, you put a DDC override on it, and you simply put a relay connected up to each of these points. A room sensor, a supply air temperature sensor again is a status point, and an outside air control. So now you can control this residential pack unit as a commercial unit with no problem. Its sequence: the fan should be on and the outside air damper open when the schedule is in the occupied mode. Cycle the compressor and gas heater to maintain space temperature set point. Now let's look at heat pumps. Heat pumps are exactly the same, except we're using the coils and the refrigerant circuit as first stage heating. Now, depending on where you're at in the country, you might have an auxiliary heater sitting here. The reason for that is that if this is in a really cold country and it's cold, real cold outside, you will begin to frost up. It's possible to frost up this coil. And when you frost up, what it'll do is it'll reverse the circuit and put hot gas into it, thus getting rid of the frost. But also, in the meantime, when it's getting rid of the frost, it's cooling the space. So when they put an auxiliary heater on, in that condition, it brings on the auxiliary heater to keep the people happy, while for the few minutes, only on for a couple of minutes to get that frost off the coil. But a couple of minutes is enough to send a cold gust of air down through the space, so they put a strip heater in there to get rid of that. So again, it has the same thermostat lugs as the other unit, same subbase. However, if it's a heat pump, it has to have a special subbase. It has to be prepared, and the reason is to heat. So in the other units, we turned on a gas furnace or we turned on an electric strip heater. No problem, we can do that. Well, this one, instead, you turn on the compressor, number one, and then you turn on a reversing valve. So on the other systems, you just had a fan running, and you turned on a heater and turned it off. But on this one, you have to turn on the compressor and a reversing valve. And one of the little problems we have here is that some manufacturers use a reversing valve that's powered on. Some have that's powered off. So that's unfortunate, but that's the way it is. So if you have a heat pump unit and you're trying to put some controls on it, you have to know, does this unit need power for it to go into heat, or does it need no power to go into heat? Does it need power to go into cooling? So that thermostat subbase has to be intelligent enough to know which one, or you have to buy the right one to connect to the right point, or else your heating will be off. So that's the only little problem that's different. So the way the heat pump works is the gas comes back, saturated gas is in cooling mode, comes back, just like the other. It goes through this reversing valve. It goes back to the compressor to be compressed up to hot gas. The hot gas goes out and goes through the condenser into liquid, into the expansion valve. Cooling goes down. Now, if it's in heating, the suction gas comes back, and if you're trying to heat it, what it does, is it reverses. It makes this one the condenser coil. It makes this one the evaporator coil. So it takes the gas, pumps it up, and runs it out to what was the evaporator coil, but now it's assuming it's a condenser coil. Now there's a bunch more devices in here to be able to switch these two coils. And if you haven't already, you need to take S-1, which is the basic of systems, package systems. It'll give you all that refrigerant circuit and tell you where the check valves are and so how it actually reverses and how this four-way valve actually works. So if you take that video, that will show you that. So now the sequence for thermostat control is the unit is enabled when the sub-bases are switched on. Unit control cycles the compressor and condenser fan to provide cooling when cooling is required. The unit control cycles the compressor and reversing valve when the heating is required. So that's what's different with the heat pump. And remember, if it has an auxiliary heater, then you have to have a spot up here for auxiliary heater also. So now if you're using DDC, same thing. We take over these terminals. We have an outside air intake, we have a supply air sensor, we have a room sensor, and this system works exactly the same as it did on thermostat, but instead it's working on DDC controls. So sequence for that, the fan shall be on and the outside damper open when the scheduled is in the occupied mode. Cycle the compressor and the reversing valve to maintain space temperature set point. Now this is a weird unit, heat pump with a gas unit in it. Now this is not that common, but it's used up in the Northeast where switching between electric and gas can save you some operational money, because there are some areas that gas prices change depending on the season and electric prices change on the season. So there's a lot of places where the electric price falls when it gets cold and the gas price goes up when it gets cold, and vice versa. So what these were intended to do, and what they do is they switch between gas and electric heat pump heat depending on the season. So in fall and spring, they're on heat pump, and only in the cold winter they are on gas. And it's cheaper for the homeowner. Now with the modern campaign against burning fuel, which probably will fail, but anyway, that could affect this, but these are out there, just want you to know about them. And of course they have exactly the same, except they have an extra switch on the sub-base to be able to switch between gas heat and heat pump heat. So it can switch back and forth to tell what it does. So this is standard thermostat control. Its sequence would be the unit is enabled when the sub-base is switched on. Sub-base switch enables heat pump mode or gas unit mode. Unit control cycles a compressor and condenser fan to provide cooling when cooling is required. Unit control cycles a compressor and the reversing valve when heating is required in the heat pump mode. The unit control cycles the gas heater when heating is required when in the gas unit mode. All right, so that's kind of how it works as a standard unit. Kind of weird that it switches between them, but it is possible to do that. Again, we can put DDC on it just like the others. It just has an extra point. Instead of one, we'd have two whites, one for gas heating and one for heat pump heating. It's no problem. We have lots of points. Normally we have 8 points. So we have on a controller, again, a room sensor and a discharge air sensor. And the reason we use these discharge air sensors is for unit status. They're really cheap. $60, $70 will get you a supply air temperature sensor, and it'll tell you anything that might be wrong. It won't tell you exactly what, but it'll tell you it's not working. So if you're in a cooling mode and you get a complaint that it's too warm, and you look at the unit graphic and it says we got 80 degrees or 75 degrees, leaving the unit, something's not working. Now, you don't know what it is, but it could be a bad compressor, it could be a clogged filter, it could be it's out of gas, it's had a leak, or it could be this fan is off. Either way, but anyway, it'll tell you. So good, it's most economical status point we've got. So a typical sequence for DDC would be the fan should be on the outside or damper open when it's scheduled in the occupied mode. Cycle a compressor and reversing valve to maintain space temperature set point, because the reversing valve, has to go into cooling or heating. Open the gas heater to maintain the space temperature set point when placed in the gas heating mode. All right, so now we're going to talk about a split system. Split systems they're still a package unit, but they have two components. They have an indoor air handling unit, and they have an outside air condensing unit. Now, these are my favorite. My house, I use all of these, and the reason for that is these are much quieter. When you put a package unit on the roof of a unit of a house, when it comes on, you feel it in the house. You can hear it shake because it's transmitting that vibration down through the roof trusses. It's very hard not to have it do that in a residential construction. But these are outside, normally on the ground, so it makes them really easy to work on. You don't have to have ladders and work up in the sun. You can work right at the unit. There is a negative to that because it means these are down near where they might be damaged by children or whatever. So, but this is the best way. I like it. It's down this way. So what happens here is we have an air handling unit inside. It draws return air, puts it through the filters, through the evaporator coil, out through the fan and out, and that's the air situation. We have an outside air intake that brings in ventilation air sometimes, and then we have a condensate drain just like the others, and we have a refrigerant circuit where the suction vapor comes back to the compressor, is pumped up, gets hot gas goes to the condenser coil, it turns it into a liquid. The liquid goes back to the expansion device, expands. Cool gas cools the unit. Standard unit. Now they also have thermostat just like the other. They're located in here. So you take the thermostat and connect it here, and then you have a set of control wires that go to the compressor to run the compressor. The internal controls of the unit run everything in this condensing unit. It runs a compressor, runs the fan, runs all the safeties for the refrigerant circuit are located in here. And that's the standard way. It has a sub base again. Sub base is exactly the same as the other units. Thermostat sequence would be unit is enabled when the sub base is switched on. Unit control cycles the compressor and condenser fan to provide cooling when cooling is required. The unit control cycles electric or gas heater when heat is required. So these furnaces can be a gas furnace. So it can have electric heaters, or it can have a gas furnace. This is an A coil for cooling. Nothing different about that. Many homes look like this. That's a standard unit. Now we can put DDC on it just like the others by putting a controller and taking care of these points. Have a room simmer again. We can have a supply air sensor if we want, and we're going to control the damper on the outside air. So we even use these commercially. We don't use as many as these as we do the regular package units in commercial, but it's possible to do so. This sequence is the fan should be on the outside or damper open when in the occupied mode. Cycle compressor and gas heater to maintain space temperature set point. Or if it had electric heater, it would cycle electric heater. So that's basically a split system. The only difference, of course, these have to be built up in the field. So you install this, and then you have to evacuate this refrigerant line because you've constructed this refrigerant line, and you suck all the air out of it, and then you basically put gas in it. Or a lot of times these will be shipped with enough gas in the condenser to do that, but we have to release the gas. And then you have to test it to make sure you have the right charge. In a regular package unit, you don't have to do that. The package units come charged from the factory. So normally on these, we'll have a suction line dryer, a filter dryer, and it actually takes any moisture that you may not have gotten out. Now, we're supposed to put a really deep vacuum on this, which should get rid of all the moisture. But just as a safety, they put these suction line dryers on there. And then we'll put a sight glass on the liquid line to make sure there aren't any bubbles, to make sure it's really liquid. So that's how we gas these units. Then we have mini split systems. Now, mini split systems were actually introduced in the U.S. as a commercial system, but we also use them residentially. I actually have one in my house. I built the house originally with a garden room for plants and flowers, and it got converted into a cat room for my wife. So my wife's cats live in this room. And one day she came and said, by the way, this needs an air conditioning unit in it. And it was impossible to get to otherwise, so I put a single unit split system in there like this. These normally are used commercially for data rooms or small single zone systems. They're very efficient units. They have a VFD compressor. So they have a variable speed compressor system. They have a VFD supply fan up here. And this is a ductless unit. It doesn't have any ductwork on it. It just blows and cools a single room and is connected to an outside condensing unit. They're very efficient at cooling. They're up around 24 SEER, 26 SEER, a little higher than most package units are available. And the typical sequence is really simple because they have a thermostat in here for this right here, and it's based on a residential from Japan. Actually, originally designed these. So the mini split system is self-contained and no programming is required except to select temperature of the room. Now, if you're using these commercially, we might put a thermostat in the room, a room temperature sensor, and watch that to see if this is actually doing its job. But we don't actually control anything. The unit controls itself. And mainly on a commercial system, when we normally use this, we're not stopping it because it's something that we need to run 24/7, like a room. Now these do come with a thermostat that's unique. It's like a remote for your TV. It's not nailed to the wall somewhere. And you can program that for when you want this on or what temperature set points you want and such like that. The programming is normally pretty minimal. And the only problem we have is don't lose the remote because you won't have a way to run this unit, turn it on, turn it off. There are no controls on here to run it. You need that remote. So on commercial jobs, I specify that they don't use those, that we have to have a wall-wired thermostat. And they can do that. You can use that. They do sell them, but you have to buy it separately. And that's residential packages. Pretty short. Hopefully that was interesting to you. Really appreciate you being a subscriber, and I really appreciate you watching these videos. Please share them with your friends. I would appreciate that. You guys have a great day, and I'll catch you on the next one.